is A and change in level of liquid is H. So we have to calculate H with respect to these terms. So first is due to surface tension, we can write Pi minus P naught equals to 2T by radius, that is R. Let's say this is equation first. And second part, there is change in level of liquid. So this must be due to gauge pressure. So you can write Pi minus P naught equals to rho GH. Let's say this is equation 2. So from equation first and equation second, we can write as pressure difference for both these two equations is same. So from first and second, we can write rho GH equals to 2T by capital R. Now for this triangle, this is R, A, angle theta. So for this theta, A is base and R is hypotenuse. So cos theta equals to base by hypotenuse. So R will be A by cos theta. So if you put this term in this equation, you will get 2T cos theta divided by E. So on rearranging, H equals to 2T cos theta by rho GA as amount of or level of liquid change due to this particular surface tension. So this is called Async formula. Is it clear?
Yes, sir.
Okay, just write it down. You all have written?
One minute, sir. Done, sir.
Okay. Now for this theta, we may define three different interaction. First, theta, which is called angle of contact, is greater than equal to 0 degree, but less than 90 degree, or say acute angle. Height will be positive, means level of liquid will ascend. And second part, if theta is 90, cos 90 will be 0, so height will be 0. So there will be no change in level of liquid. In third part, if theta is greater than 90 degree and less than equal to 1 degree, so cos theta will be negative. So height will be negative. It means there will be decrease in level of liquid, or it will be descent formula. Is it clear? Atif, any doubt?
No.
Now the next condition will be you will be asked to calculate mass of liquid in that tube, how it is related with radius. So mass of liquid related to radius. As we have h equals to 2 times t cos theta divided by rho GA. We can write density equals to mass by volume. So mass by volume, volume of this cylinder is pi r square into h, or the volume of level of liquid that has been raised up. So if you put the value of density to be this part in this expression, you'll get 2t cos theta by mass upon pi a square h, g into a is equals to h. So this h and this h will cancel out. A and A will cancel out. So if you move this mass to left hand side, you'll get m equals to 2t cos theta times pi into A by g. This whole term will be constant, so mass will be directly proportional to its radius. Is it clear? Mohammad Irfan, any doubt?
No, sir.
Okay, just write it down. I'm giving you a question related to this. You all have written?
Yes, sir.
Okay. If theta 1, theta 2, and theta 3 are angle of contact corresponding rise in level of liquid are H1, H2, and H3. Find relation between these rise in level of liquid. It means you have to define how H1, H2, H3 being related with one another. Choose your answer according to these three options. These all three angles are acute. Just use the above formula and try to define which of these relations will be correct. Atif, any idea? I guess your answer. First, second, third. Reba?
Third, sir.
Okay, third. Mohammad Irfan? Yusuf?
Sir, second.
Okay. Atif? First, second, third. As we have formula for Async formula, H equals to 2t cos theta divided by rho GA. So H is directly proportional to this cos theta. And we all know cos 0 will be maximum, that is 1. So if you increase the value from 0 degree to 90 degree, corresponding value of cos theta start decreasing. So we have cos theta 1, theta 2, and theta 3. Theta 3 is largest one with compared to theta 1. So you will say cos theta 1, cos theta 2, and cos theta 3 corresponding to these three values will be related like this. It means for smaller value of theta, cos theta will be larger, and for larger value of theta, cos theta will be smaller. Therefore, H1 will be maximum and H3 will be minimum, like this. So option third will be correct. Atif, is it clear?
Yes.
Okay. Yusuf, is it clear?
Yes, sir.
Since cos 0 is maximum 1 and cos of 90 is 0. So on going from 0 degree to 90 degree, the value of cos theta decreases. That's why if theta is small, cos theta will be large. Nida, any doubt?
No, sir.
You all have written?
Yes, sir.
Yusuf, done?
Yes, sir.
If there is a rise in level of 5-gram liquid in tube of radius A. if tube is replaced by another having A by 2. Find mass of liquid. Raised in the tube. I had defined a relation between mass and radius above. Just use that and try to define it. Atif, what was the relation with mass and radius for rising up of liquid in a capillary tube? Mohammed Irfan, Reba, just say this part. We had mass directly proportional to radius of capillary tube. So using this concept, we can say 5 gram for radius A. So if you decrease its radius by 2 times, mass will also proportional to this. So it will also become 5 by 2 gram. Is it clear? Atif, any doubt? Yusuf, is it clear?
Yes, sir.
So this is all about the hydrostatic parts or surface tension. You all have written?
Yes, sir.
Yusuf, done?
Yes, sir.
Okay, so let's start hydrodynamics. Or flow of liquid. In this particular liquid, the first term is Newton's law of viscosity. According to this Newton's law of viscosity, it states liquid always flows in layer by layer structure. Suppose you have a layer having area A, there will be another adjacent layer to it like this. So for this part, it will have some velocity v, but for this layer, it will have velocity v plus dv. It means each consecutive or adjacent layer opposites its neighboring by a force which is called viscous force. So there will be a viscous force acting on this particular part along this direction. So due to which there will be difference in difference in velocity for the different layer of liquid. Suppose width of liquid from this point to this point is dy, and the area of liquid film is A. So according to Newton's law of viscosity state, liquid always flows in layer by layer structure in which each consecutive layer opposes its neighboring by a force which is called viscous force. This viscous force will be directly proportional to area of liquid film and also to the velocity gradient. Let me define you. In physics, we use two terms. First is rate, means change of a particular quantity divided by time. So it is called rate. Similarly, gradient is change in a particular quantity with respect to length is called gradient. So let me define you about this Newton's law of viscosity. Liquid flows in layer by layer structure in which each layer opposes its neighbor by a force called viscous force. It is directly proportional to the area of liquid film and velocity gradient. So we had two different parts. First is area of liquid film and second is velocity gradient for this viscous force. So we can write F proportional to area and F proportional to dV by dy as change in velocity with respect to length. So it is called velocity gradient. Now, if you combine these two equations together, you will get F proportional to A dV by dy. Now, if you replace this proportionality sign by any constant term, so in this part, it is equals to eta A dV by dy. And since this force is always opposing in nature, so there will be negative sign at this point. This eta is constant of proportionality is called coefficient of viscosity, and its SI unit is Pascal second. its CGS unit is poise, and there is a relation in between these two terms as 1 Pascal second equals to 10 poise. First, write it down from this part. Okay. You all have written?
1 minute, sir. Done, sir.
Muhammad Irfan, you have written?
Yes, sir.
Okay. Now we can rearrange this particular formula to define another relation. We can write eta equals to f divided by a whole divided by dv by dy. F by a is nothing but, since you have surface like this and there is opposing force tangentially along this direction. So this force tangential to this surface per unit area is called stress. So we can write this as shear stress. Next, in denominator part, we have del v by del y or dy. Velocity is delta x divided by delta t times dy. So this is nothing but change in length with respect to original length. So it is called strain divided by time. So we can say it is strain per unit time or strain rate. So we can write this relation as the ratio of shear stress to the strain rate. So you'll be asked to relate this particular coefficient of viscosity in these two terms, or how this particular two different values will be related with this coefficient of viscosity. Next is, on what factor coefficient of viscosity will depend. So first, coefficient of viscosity will be inversely proportional to temperature. Any doubt to this point? Yusuf?
No, sir.
Okay. Now let me give you a question related to this. Suppose there is a flat surface having a pulley. There is a block over it attached to a string. Some mass m. There is a liquid at this point having thickness 0.2 mm. If it is slide along this direction at some constant velocity, 2 meter per second. Find mass of block hanged to slide the block over the liquid if eta is 0.005 Pascal second and area of liquid film is 1 mm squared. Let me give you some hint how to approach this problem. there will be a force acting on this blob along downward direction that will be capable of sliding this blob over this liquid or to overcome that viscous force experienced by it. So force is mg. Area of liquid film is 1 mm squared. So just multiply it by 10 to the power 6 meter squared. Eta is 0.05. Thickness is 0.2 mm. And velocity of body is 2 meter per second. Just put all the values in the above formula and simplify it. Since we have to calculate mass, so it will be eta A B by G times delta Y. Eta is 0.05, so we can write it as 5 in 10 to the power minus 3. Area is 1 in 10 to the power minus 6. Velocity is 2 meter per second. Divide by gravity 10. And width is 0.2 mm. So this 2 and this 2 will cancel out. This 10 and this 10 will cancel out. So on rearranging, you will get 5 into 10 to the power minus 6 kg. Yusuf, any doubt?
No, sir, clear.
Atif, is it clear?
Yes.
Mohammad Irfan?
Clear, sir.
Okay. You all have written?
Yes, sir.
Okay, so just stop for today till this part. In this class, I will define you about types of flow of liquid. Then we'll start Bernoulli's principle, the most important part of this particular chapter. Okay?
Okay, sir.
Okay then.
Thank you, sir. Take care.
Thank
Good
you.
night.
Good night.
Thank you, sir. Good night.
Thank you. Good night.